Hi, in this video we're going to look at ways to improve how we set data within our programs. Unless you're working with an external database or making your own data files as you go, your programs are probably littered with chunks of code devoted to setting the values your program will use. I've done this a lot in the past, and it can be a nice shortcut, bypassing the need for external files, but there are good and bad ways to go about this. Let's look at the most rudimentary way to set your program's data. You have arrays, and you populate those arrays with data by using rows and rows of value assignments. In this example, so I was making a proposition tracker for Final Fantasy Tactics. So in this example, these are the side missions that you can do in Final Fantasy Tactics by visiting the tavern. The game calls these missions propositions. There are two different translations for the game, one for PS1 and one for PSP. So we have two different names for each mission, and also each city has two different translations, two different names. And this program will take your party stats and the proposition you're trying to do and give you what the outcome will be, because it takes your party stats and it calculates your success chance as a result of that. And I only have the missions for Egros Castle here, which are 8 in total, 1, 2, 3, 4, 5, 6, 7, 8. But there are 12 times this many missions in the game, so you can see how much space this will take in the code to do the data setting like this. Plus, all these numbers, like chapter 4, type 4, stat 2, city 1, and they stand for the chapter the mission becomes available, the type of mission, the favored stat for the mission, brave, faith, or neutral, and the type of reward the mission will give. And the numbers stand for values that will be correctly used by the program, but to our eyes, even to me who wrote this program, they don't mean much because they don't relate to what they stand for in the game. So this style gets the job done, but it is very bulky, difficult to scan through and check visually, and it involves a ton of repeating patterns of the same thing. And what do we know to do when a program involves repetition? That's right, we make a routine out of it. So here's our routine, right here. It's one copy of the chunk of code we had for each mission, but we're simply plugging each parameter into the arrays, with the first parameter being used as the index of the mission in the array. Now look at what this has done to the code blocks for our 8 missions from Egros Castle. Isn't that nice? Each mission has its own neat little row, and all the data is organized into columns. So here's the 2 names, here's the index of the mission, and so on. Now this has solved our problem of bulk. It's reduced the line count for the database by a factor of 8. So we have this table going on. But there's still more we can do here. So the first parameter, the mission index, it only ever increases by 1 each time we call the routine. And since I'm grouping the missions by city, the last value here is the city, it won't change within this group. So this whole group of missions is just going to have a 1 at the end. It's repeating again. So I'm going to add 2 global variables, one for the mission index and one for the city. In the routine, I'll get rid of the parameters. So here's the new version of the routine. I'll get rid of the parameters for the index and the city, and I'll automatically use these variables instead. So the mission index will just be incremented by 1 each time this routine is called. And then out in the data setting part, where all the mission tables are, I'll just set the city at the top of each group of missions, which makes a nice header. I've also gotten rid of parameters from each call, making this even more compact. So here we go. So at the top here, I'm setting the city, and then there's no index. It just increments by 1 each time. But we still have these pesky numbers at the end here, and no idea what at a glance they mean. In fact, now it's even less clear because we don't have a variable next to them that's storing the data. So we don't have any idea what this table of numbers means. So here's the final step, adding abstraction. At the top of the program, I'm going to throw in these constants. First, 2 constants for which console's translation is involved. Then there'll be constants for the cities. There's only one here because I was only working with this one city in the example. Mission types. There's a bunch of mission types here. Which favored stat for the mission, which chapter it's in. In Final Fantasy Tactics, new missions become available at the start of chapters 2, 3, and 4, and also midway through chapters 3 and 4. And certain missions are only available when the date is in a specific zodiac sign. So that's what all this means. And then rewards as well. With all that in place, let's move over to the actual program code. Okay. So here in the header, you can see the constants we just looked at. So here's the console. We've got mission type here, favored stat. Here's all the cities in the game, and so on. You get the idea. So lower down, here's the routine. Now it's got the constants for the console plugged in. And then lower down at the bottom, here's the table for all the data setting. This is all 96 missions in the game. That's all the data right there in our compact table format. Now imagine this, how long this would be if we went back to the first method and set each value on its own line. So now we can easily read the values for the chapter. Here, chapter in this column. The city is at the top of each section. We've got the mission type, the favored stat for the mission, and the reward. In fact, this is so easy to read that you could actually use this code block as a reference guide when just playing the game. You wouldn't even need to use this program. And also because each call increments the mission index by 1, all of these lines can be reorganized any way we want. We can switch them around without having to adjust a bunch of numbers. Like if I had the numbers still in here and I wanted to move things around, I had to adjust the numbers at the start of each call, but it does it automatically for me. And if you want, you could put a comment across the top telling what each column is, like what kind of data that is, but we don't really need that here. If your data benefits from it, you can add something like that in. So there you have it, a demonstration of several ways you can use table routines and abstraction to make data setting in your program code much easier to work with, especially if you have a lot of data that's all in one format like this. I hope you enjoyed this video. Thanks for watching, and take care.